This is chapter 15, multiple regression analysis. Multiple regression model is given by y equal to mean of y that depends upon x, mu sub y given x, plus an error term. And that's equal to beta sub 0, the y-intercept, plus beta sub 1, x sub 1, plus beta sub 2, x sub 2, and so on, up to p x variables, plus an error term epsilon. So this model differs from the simple linear regression in only one way, and that is we have more than one independent variable x. Now, the regression equation then is the expected value of y. In other words, the mean of y given x. So that part, except for the error term. So that is your multiple regression equation. And so the estimated multiple regression equation is y hat equal to, you replace all the betas with b's, b sub 0, b sub 1, and b sub 2, and so on. And this is our estimated multiple regression equation using which we can develop a point estimate. Now, how do we come up with our estimates for b sub 0 through b sub p? Well, we will use least squares method. The least squares method is to come up with formulas for these b coefficients such that the sum of the squares due to error is minimum. That is y minus y hat. So that's our residual. In other words, error. Square that error and sum. That is sum of squares of error. And we want to make sure that the values we determine for the b coefficients are such that the SSE is the least possible value. The formulas for multiple regression are quite complex, so we will simply use the data analysis command in Excel to develop the least squares values for the b coefficients. Now let's look at an example. In this example, we're going to look at a trucking company, and that wants to develop a better way of coming up with work schedules that minimizes the route time and route distance for the trucking company. So they collected a random sample of 10 driving assignments from the past, and for each driving assignment they collected 3 columns of data: the travel time, the number of miles for that particular delivery route, and how many deliveries were made during that route. Now, the purpose of this is to come up with a regression analysis that will estimate what the travel time will be given the miles traveled and the number of deliveries that are to be made. Now let's look at the Excel file. So here is the data: miles traveled, number of deliveries made, and the travel time in hours. So dependent variable here, y, is travel time in hours. We have 2 independent variables. So the first independent variable is miles traveled. The second independent variable is number of deliveries made. Now we want to develop a least squares estimate. So we're going to run regression command from data analysis. Data analysis, regression. Input range for y, travel time. X range, now we have to cover both independent variables. Labels. Output range, let's select G5. We're not going to do any residuals at this point. Click OK. Now format, So here are the coefficients, intercept, b sub 1 and b sub 2. Then our y hat is now we need to interpret the two slope coefficients. The first slope coefficient is 0.061. Remember, the slope coefficients are in the same units as the y variable, which is travel time. So b sub 1 0.061 is number of hours. So we can convert that into minutes, which will be easier to interpret. So let's take that 0.061 and multiply by 60. So b sub 1 is about the first independent variable, that is miles traveled. So for each additional mile traveled, the travel time will increase by 3.67 minutes. Now we have to add the caveat that the other variable will remain the same, that is with the number of deliveries remaining the same. Now b sub 2 is 0.923. And that in minutes is now b sub 2 is about number of deliveries. So therefore, for each additional delivery to be made, the travel time will increase by 55.41 minutes, and of course the caveat being the miles of the route remaining the same. So travel distance remaining the same. Now let's see how to use this regression equation for a point estimate. Suppose we want to estimate the travel time for a route with 80 miles. So that is the x sub 1 value is 80 miles. And we have 3 deliveries. And we have b sub 0. Okay, let's get b sub 0, b sub 1 and b sub 2 from there. Then our estimate is b sub 0 plus b sub 1 times x sub 1 plus b sub 2 times x sub 2. So that will give us the y hat value. Remember, this is in hours. If we want this in minutes, then we have to multiply by 60, and that will give us in minutes.